Hello! All right, this is going to be another exciting one, but before we dive into all the coding, all the building of apps, playing with our phones, and feeling confident with React Native, there's the first thing we have to do, and that is to understand the landscape of mobile development. Why do we use React Native? Why should we use React Native? And what are all our options? Get ready for this. I'm going to give you a bit of a history lesson. So how do we get here? How do we get to a land where we have apps on our phone? Well, if you know, just like on your computer, applications or apps are designed to run on a particular operating system. We have iOS for the iPhones, and then we have Android for all other phones, like Samsung, like Google phones. And these are the two major operating systems in the world. But the thing is, you can't take one app, let's say an iOS app, and just run it on an Android app. Just like you can't use a Windows application on an Apple. I mean, sure you can, but usually there's different download options. If you have a Mac, then download this app. If you have a Windows, then download this version of the app. And without getting too much into the details, this has to do with the underlying architecture that these operating systems are built on. iOS runs apps in a certain way. Android runs apps in a certain way. So in order for us to target 99% of smartphone users that use iOS or Android, we have to build two apps. One for Android and one for iOS. That's not very fun, is it? But that's the reality. Most companies, when they start, they decide, hey, should we target Android or should we target iOS first? And then from there, build their second version of their app that works in the other operating system. Just like on Windows or Macs. So initially, when Apple came up with the App Store, they said, hey, if you want to build an app, well, you need to use this language called Objective-C, which they created. Use Objective-C and you can code and build an app that can be put on the App Store. Then Google came along and said, oh, I want an App Store too. So they created the Google Play Store and they said, with the Google Play Store, you're going to have to use Java programming language to build an app. Now, here's a trick question. Okay, not that tricky because it's going to be obvious. How do you think these operating systems are written? What language is iOS written in? That's right. iOS, it's written in Objective-C and C. And that's why you build your apps in the same language that the operating system is built in. Same with Android. Android is written in Java. That's why you write apps for Android in Java. Then a few years passed and Apple said, hey, we have a new language, Swift. It's a little bit cleaner, nicer than Objective-C, so that Apple can say, hey, use Swift. It's going to be a lot nicer as a developer for you to build apps on our store. So now you can use two languages, again, both created by Apple. Then Google came up with Kotlin. Kotlin is, again, a nicer version of Java. Makes things a little bit nicer for developers, for programmers to build Android apps. So now, if you want to build an iOS app, you would use one of these two languages. If you want to build an Android app, then you'd use one of these two languages. But here's the thing. Are you stuck? Is that the only option for you? Actually, no. This was just a small subset. Because people can get creative. You see, up until now, we talked about the native way of creating an app. A native way just means the intended way, the way that the phone intends you to build an app, either using Objective-C and Swift or Java and Kotlin. But there's one big problem. If you want to target both phones, then you essentially need two separate teams of developers, which costs money, each one specializing in their own language to build an app that is essentially doing the same thing for two things. Companies didn't really like that so much. So a few alternatives came to be. By the way, I hope you're not sleeping during this history lesson because things are about to get exciting. One of the first solutions that came to be in this environment was the web. We browse the web. We use Chrome, we use Safari, we use Firefox. So Cordova was one of the first things that came out that said, hey, instead of playing around with all this native nonsense that is really, really hard to program in, why don't we just use HTML, CSS, and JavaScript that we use on the web to display information to user, to display web pages, and just pretend like they're native things. So things like Cordova and Ionic do something called using the web view. And WebView is a browser that's actually bundled inside of the mobile application. And we essentially create a hybrid app. So instead of using a native way, a native view that an iOS or an Android app might use, instead, we have a browser that has some of the browser tabs missing. But it still makes it look like an app on your phone. This way, you're able to code an app in JavaScript instead of, let's say, Swift or Kotlin. And that's because JavaScript is very popular. A lot of people know JavaScript. So they can create, if you know how to create websites or web apps, well, then you can create a hybrid app on the mobile phone as well. And those hybrid apps can actually be put on both app stores. How awesome is that? The problem with the web, though, was that, well, you're essentially shipping a browser view inside of this phone, and both iOS and Android apps are optimized to run native code. So no matter what, this web view version of apps was always slower, was clunkier than native apps. Also, Android and iOS have different looks. For example, on Android, the navigation is usually on the top, while iOS navigation is usually on the bottom. And there's all these different looks and feels of Android and iOS apps. So with this web view option, you kind of had to settle on just one look and hope that it looks good enough. So it's almost like a downgrade from native apps, but at the convenience of having to only build it once and have it in both operating systems. Now, one of my first projects that I ever worked on was a Cordova app. And I remember this specifically being an issue where we always had performance issues because we used a web view instead of native views, which are just much faster. But also, we always had this weird app that never looked like an iOS app, never looked like an Android app because we're trying to please both things. Now, things like Ionic have made this experience better, but no matter what, when you use the web on mobile, it's just never going to have the performance that you want. So you never build a serious app, a native app, using these technologies. Now, another option that came quite recently was this idea of a progressive web app. And progressive web app is essentially a web app, that is a website, that you're able to download on your phone or potentially even use it offline like you would with a native app. For example, we can go to a progressive app store, and here we have all these progressive apps that are on my browser, on my Chrome browser, because they're web-based. They use things like service workers, app manifest, these web tricks to pretend like they're mobile apps. And yes, you can download them on your phone, but they're not really native. They're more web than anything. It's something Google came up with, but again, when it comes to performance, it's just not there. So now we get to the exciting part. What if we can have the best of both worlds? What if we can have native code that is performant, but also use this idea of write once and run on both iOS and Android? And that's where we get into this box over here. But this video is getting long, so let's take a break, and I'll see you in the next one.